So we're still dealing with Euclidean geometry. So another example here, they're saying that in the following diagrams, O is the center of the circle. Determine with reasons the value of x. So we need to determine the value of x here and also the value of x here. So let's first start determining the value of x on this one first, okay? So if you can look at this diagram, we have this angle here, which is angle 100 degree, which is at the center. And then we have this angle here, BAC, which is at the circumference, right? So in order for us to find the size of x, you have to remember that, or that theorem that states that angle at the center equals to twice the angle at the circumference. So in other words, you are going to say for 1.1, we are going to say angle at the center. So we have BOC. So we're going to say angle BOC is equals to 2 times the angle at the circumference. So we're going to say 2 times the angle at the circumference, which is BAC. So 2 times angle BAC. Okay, what's the reason for this? Is because angle at center equals to twice angle at the circumference, right? And then you know that BOC is 100 degree, and then we know that this will be 2 times BAC. So we know that the BAC is x, so we're gonna put x here. So we'll have 100 degree equals to 2x. So in order for us to find the value of x, we just need to divide both sides by 2. So we know that this will cancel this. Our x will be equals to 50 degrees. Okay, this is for 1.1. So as for 1.2, still gonna apply the same principle. So remember that we have this angle here, AOB, this one which is outside, right? So angle AOB outside, or maybe let's focus on angle O1. Let's call it O1 because it talks about this one outside. I think AOB is this one with 120. So we have angle O1. This angle O1, it's twice the angle ACB. Remember, this is because of theorem number 2. Angle at the center equals to twice the angle at the circumference, right? So angle O1, so we're gonna say for 1.2, when I say angle O1 is equals to twice this angle here, ACB. So we're gonna have twice ACB, okay? But there's an issue. We don't know the size of angle O1. We need to first determine the size of angle O1. So we know the reason for this first is the same as this one. Angle at center equals to twice angle at the circumference, right? So let's first calculate angle O1 before we can proceed with this step. So angle O1, to find the size of angle O1, we can use this 120 here. So we can see that this is a revolution angle, or angle around a point. So to find O1, you can add these two angles and then equate them to 360, right? So we can say angle O1, angle O1 plus, this is plus 120 degrees will be equals to 360 degrees, okay? So we know that this is what? Revolution. Or you can say angle around the point, okay? So angle O1 will be equals to 360 degrees. We're gonna take this 120 on the right hand side. So it's positive, so it's going to be negative 120. So angle O1 will be equals to 360 minus 120 will be 240 degrees. So this is the size of O1, right? So remember that we need to continue from here. So let's continue from here. We are going to say angle O1. So remember that O1 is 240. So we're going to put 240 degrees equals to 2 times ACB is what? ACB. Remember, it's x. So 2 times x, right? Which will give us 240 degrees is equals to 2x. Okay? And then we divide both sides by 2 since you're looking for the size of x. So our x value will be equals to 120 degrees.